It's space weather. Ton of stuff to cover today. So no screwing around. We're running out of time. We got to get the video up. And the SGO is not loading the images of the sun we normally start out with very well. Here you get what we've got in 304 angstroms. Nothing too exciting, no sunspots. Let that play through. Some filaments in the northeast and some magnetic activity in the southwest. Here's the 171 angstroms view. Small active region just north of the solar equator facing Earth. Looks like some activity rising in the east. Be keeping an eye on that. Could be a sunspot. And an interesting magnetic looping situation going on down in the southwest. See if we can get an image of that right in this area. And let that play through since the image actually loaded. Thank you, NASA SDO. And here's our magnetic lines. And we've got a working theory as to why we're seeing so much density on the northern part of the sun and such little density on the southern part. We'll get into it. First, let's cover another story about how magnetic fields run the universe. So we've wondered for ages how birds are able to do what they do, especially migratory patterns. This article came out earlier this year. It turns out birds can see magnetic fields. It's actually part of their visual cortex. The substance in their eyes gives them the power to perceive magnetic fields, a protein called Cry4. We'll leave links to the article. Why are we covering this? Well, because again, magnetic fields run the universe. And if they run the universe, they certainly run your planet. See that image there? Doesn't exactly look symmetrical, does it? We're going to get back to that in a minute, because there's a lot of talk about this, and there's a lot of people doing research at a feverish pace right now about this. Normally, that arrow would be like this, but it's not. It's like this. We have a little bit of information about what could be causing this. There's conjecture as to whether it's coming from inside the Earth or from outside. I'm not going to take either position, because we just got to look and see what happens and see if anybody figures something out that we haven't. Now, let's look at the weather, the regular old space weather news data. As we head to spaceweathernews.com, we notice just a tiny uptick in the X-ray flux. That's probably from that active region that's facing Earth. Phi angle's just bouncing around, no real signal there. BT-BZ's fairly convergent. Looks like the total's going up a little bit. Solar wind density has just recently dropped down, and solar wind speed has increased to about 500 kilometers per second. Here's a real-time solar wind. You can see the solar wind density is 5.14 protons per cubic centimeter. And solar wind speed 501 kilometers per second. All right, let's go back 10 hours since that's what data we have here. There were 2 deep quakes in the South Pacific last night at 500 plus kilometers depth, putting those places on alert. Also a rare quake at Easter Island in the 6.2 magnitude. 5.4 in the northern mid-Atlantic ridge, another fairly rare quake. Vanuatu, a 4.8. Basically, this is an earthquake lull. And if there's any kind of a coronal hole magnetic connection or something, earthquake risk should go up because of that. Look at some data on solar ham. Not to be confused with Canadian bacon. Nothing too exciting there. Let's just look at the synoptic map, if I can get it to work. And see what Patterson has to say. There's a small coronal hole there. So there's a small coronal hole rotating in that could magnetically connect. We'll be keeping an eye on the phi angle for that. Now, let's go back to the magnetosphere. Notice how this is angled at like 20 degrees. This is normally like this. So the first thing we look at is the heliospheric current sheet. For those of you who are not aware what the heliospheric current sheet is, well, we're going to cover it. If I can find it. I think it's this one. So, the heliospheric current sheet shrinks and grows with solar activity. At solar minimum, the current sheet is thinner, less charged, obviously. And as the sun rotates, it's constantly spewing out plasma on this plane, which happens to be the same plane that all the planets are rotating on. That's your interplanetary magnetic field is located there. All your normal planet orbits are located there. And so it's something that we follow all the time. It does also have a charge. The top of it's either positive or negative, and the bottom's either positive or negative. And the Earth always goes up and down through the heliospheric current sheet. Now, let's look at a real-time, actually this is a model. And you can see that the prediction here, because this is a prediction, notice the heliospheric current sheet right here. It's like north of the Earth. I mean, you can see the charge associated with this red area. That's going to move around a bit. There's the blue area charge, north and south poles. Magnetic poles, that is. And the Earth goes up and down through this heliospheric current sheet. Every time we do that, we get a magnetometer spike, and there's anomalous looking data every time that happens. However, if you look at this prediction, the current sheet is staying up here. There's no way in the world I'm going to attribute that to changes in the Earth's internal magnetic fields. It raises questions about what powers the Earth's magnetic fields. Are they really caused by an internal iron dynamo caused by flowing magma? Well, we can't really say that for sure. But this is what I attribute this. I mean, if the current sheet is like this, it's going to absolutely change this bow shock angle, and that's what's going to happen. So anyway, there's a big conversation about this going on in Ice Age Farmer. I'll leave a link to that also, as we leave links to everything every day. A long discussion about what's going on with the magnetosphere. This seems to have started the same time that there was that crazy earthquake anomaly on November 11th. And sadly, I wasn't looking at this particular data at the time, and I didn't see any of this happen. But it's a very interesting article. It's got a bunch of links. Please read it. If you're interested in stuff like that, Had to make the video a little bit shorter today because we had to get it out. And I spent about a solid hour doing research on the magnetosphere before putting this up because I wanted some greater information. And I'll tell you what, it ain't too easy to find any. NASA, SDO, we implore you to fix your servers so we can load these images in a timely fashion. Thanks everybody for watching. Please don't forget to like and subscribe if you enjoy the content. More coming daily. And, remember, when you're waiting for these images to load, don't drink. And if you drink, don't drive. And furthermore, don't drive. It's one of the most statistically dangerous things you could do. And I might be on the road, and I don't want to see you there.